Good morning, everyone. Welcome to this morning's event, Robotic Boats Make a Splash in Amsterdam. Just a couple of quick housekeeping duties. I'm just going to ask everyone to make sure that you're put on mute, if that's okay, for the duration of Dennis's presentation. And then with that, that'll make it just a little bit easier. To introduce myself, my name is James Scott. I work and run the MIT Real Estate Technology Initiative at the Center of Real Estate. I'm a fellow alum of the Center and a fellow European. So I get to be part of this group anyway, which is great. So really looking forward to this morning's event. With that, I just also wanted to outline a couple of quick things to everybody before we kick off. There are a number of really fantastic events coming up over the next couple of months, and it'd be really great to have as many of you involved in them as possible. First and foremost, we have the MIT Build Nano Conference, which is coming up in April. This is a really cool event. This is the ultra small scale engineering components with that are really trying to facilitate city scale impact, which is really fantastic. With that, I'm sure an awful lot of you over the last few years, who have maybe not seen the nano building at MIT. It's one of the really fantastic innovations and developments that have taken place over the last number of years. And if, of course, any of you are ever in Boston over the coming months or years, please don't hesitate to get in touch with me, and I'd love to be able to take you around and showcase some of the things that have been built over the last few years. That'd be really good fun. Second, of course, we have the World Real Estate Forum, which is coming up in the fall of 2022. This has really just been starting to put together at the moment, and the program for this is starting to look absolutely incredible. We've got really, how do I put this? We have the top names in so many different fields coming through this year, like be it in, from a macroeconomics standpoint, from the technology standpoint. I think it's going to be one of the best programs yet that we've seen. And then finally, this is a new program, which is the CRE Climate and Real Estate Conference coming up in the fall. So, over the course of the last number of years, CICI, who has taken over the center, has really focused on sustainability, and ESG initiatives have become so prevalent and so important within everything that we're doing within real estate. So this is really, shaping up to be a fantastic event as well. With that, I'm just going to turn it over to Jennifer for 1 second in relation to some interesting funding that is coming up. So I might just hand that over to you, Jennifer.
Okay, great. Well, thank you all for being here. There are two things I'd like to highlight in my role as helping fundraise for the Institute and for the Center for Real Estate in particular. As you might know, US and private institutions like MIT is very dependent on the generous philanthropy of our alumni and friends to help others get the type of education that many of us have been blessed with. And so also the CRE program in Boston at MIT is a bit more expensive than some of our competitors. And so we'd really like to make this program available to top talent from around the globe who might not necessarily be able to undertake the tuition on their own. So there are opportunities for you to help. And there are two funds I'd like to highlight here: the CRE Graduate Student Fellowship Fund, and that provides tuition support for our master's and PhD students. And then the CRE General Fund, which really helps us fluctuate and respond nimbly to the current opportunities and needs of the department, including research and buying good data and things that really keep us at the cutting edge, whatever those needs are. So I also want to highlight this. It's timely because on the 10th of March, we are having the 24-hour challenge, which is a fundraising day. But we have a number of challenges that are going to tip forward if we reach certain metrics of participation. And so any gift to the School of Architecture and Planning on March 10th will help us reach the goal of having 100 people donate to the School of Architecture and Planning, and a wonderful alum will give us $10,000. So if during the course of the year you've thought about supporting the school, March 10th would be a wonderful way to do it. And if any of you are located in the United Kingdom or are taxpayers in the United Kingdom, we do have a foundation that you can give through there that provides some tax benefits. So please reach out to me directly, Jennifer Butler, and I can tell you more about the UK Foundation. So thank you for the little public service announcement, and I want to really keep the show going, but thank you very much for considering supporting the Center for Real Estate.
Brilliant. Thank you so much, Jennifer. With that, we will get on with the main event. This morning, Professor Frenchman is going to share with us about this really innovative and exciting invention that was developed at MIT to navigate the famous canals that are, within Amsterdam and within different parts of the Netherlands. What it is it's a full-scale, fully autonomous robotic boat called Roboat. And it's one of the most futuristic things I've come across in the last few years. It can carry people, it can collect waste, it can deliver goods. And of course, Professor Frenchman will outline that to us over the next few minutes. Without sounding silly, it's very rare that I have to introduce somebody that really needs no introduction, especially in light of the audience that we have here. But of course, for some of you who maybe just have forgotten that, Professor Frenchman, he is the class of 1992 Professor of Urban Design and Planning at MIT. With that, he is, he teaches extensively around the globe. He is, he's a very well-renowned published author, and he's a leader and a true innovator within his field. I can safely say, he's had an incredible impact on my own life as a teacher and as a friend. And, for all of you who I hope are lucky enough to have had half as much influence in their lives as Dennis has had on me, then you can count yourself very, very lucky. So with that, I'd love to introduce you to Dennis this morning. And thank you so much for being with us, Dennis.
Well, thank you, James, for that really overly kind introduction. And I'm really happy to share the work that we've been doing over the last years on Roboat. And if I can just now share my screen. How's that, folks?
That looks
absolutely
great.
Perfect.
Oh, I did it perfect the first time. That's incredible. Okay, so Roboat, as James pointed out, is a project of MIT in partnership with the Amsterdam Advanced Institute in Metropolitan Solutions, an institute that was set up between MIT, the city of Amsterdam, and Delft University 5 years ago. And this was kind of the lead-off project, but there are many other research engagements that are underway. And for this project, the principal investigators were Dr. Carlo Ratti from the Sensible City Lab, Daniela Roos, who's professor of electrical engineering and head of CSAIL, the Computer Science and Artificial Intelligence Lab at MIT, Andrew Whittle, who works with civil and environmental engineering and is a very well-known expert on sensing, and myself. Here's a smiling picture you can use. James, you had trouble finding one. Now, the project is about Amsterdam. It was initiated in Amsterdam, which is well known for its beautiful canal system, and I'm sure many of us have been there, which is integrated with the city. But the canal system was not put in place originally to be necessarily a thing of beauty and improving public life. It was a serious infrastructure system developed over hundreds of years to provide access to every part of the city of Amsterdam. And if we look back, into the early 19th century, we can see that this was a working logistical infrastructure for the city for delivery, construction, waste removal, transit, food distribution, storage. A lot of storage occurred on the canal, and living. It was a part of everyday life and vital to the city. Now, what has happened in the meantime is that virtually all these functions have been moved to the land. We see waste accumulating on sidewalks, delivery trucks, bikes wiggling around. because the city was not designed for all of this activity happening on the land, and there just isn't enough room. And this has all been exacerbated by e-commerce and deliveries and so forth, and it's unsustainable. Meanwhile, the canals are basically for tourism, and Roboat can serve many of these urban functions more efficiently, returning the canals to an active, functioning part of the city, in many ways a more historic relationship. And it's not just for convenience, because the impacts, what is happening is that the impacts of contemporary traffic and these large tourist boats are eroding the ancient walls and infrastructure of the canal system throughout the city. And the interesting thing is there's no way to predict when sometimes these walls may collapse. So the city is itself is at threat, and there's a need for a new kind of solution. It's not only a physical solution, but it's also a people solution, because Amsterdam is so popular as a visitor destination that very weak landside infrastructure becomes way overcrowded on certain days. Like you see these guys swimming, guys and gals swimming in the canals here, so overburdened that it is unsafe. And then there's the whole need to distribute goods and produce and food and products to the people within Amsterdam itself, which is also becoming increasingly difficult. So Roboat was originally conceived, here you see a sketch 5 years ago, as a way to address these multiple problems. And from the beginning, as you see it filled with packages rather than people, we saw this as a way of servicing the city using 21st century technology and bringing back the ancient logistical system of the canals. For packages, for people, of course, but also as physical infrastructure. The idea from the beginning was to have these boats be able to connect themselves and be a sturdy platform on the water. So, for example, suppose during a rock concert or some high volume event, we need a new way of relieving people and getting them out of the area. The boats could assemble themselves automatically and provide this, or more space for markets and other uses that overflow from the small streets that surround. And this led to a 5-year joint collaboration across MIT and in the city of Amsterdam. These are one of our labs at AMS there, to develop this completely unique product. And you might say, well, you know, cars are autonomous, you just build on that technology. Unfortunately, no. This is a challenge that's completely different. And it moved from these, I don't know if you can see my cursor, these small, almost toy-like quarter-scale robots in the beginning, up to the full-scale prototype, which is now operating on the canals. And in a nutshell, we're talking not just about a boat, but a system of autonomous transport to service the city, reduce congestion, make service more efficient with less impact. And in order to do that, we had a couple of principles starting out. First of all, to put as many mechanics on the boat as possible, to adjust to different uses and conditions. And you can imagine the banks are not all the same. So how do you access this boat if you have a 6-meter difference between the land and the water in one place and 5 centimeters difference in another place? Second, to adapt to existing systems, minimizing the infrastructure that would be necessary. And there are existing systems that are functioning. If we can use them, we should. And third, to conceive of the rowboat system as a towboat, first of all, a power source, plus the potential for trailers. So a tugboat and a trailer boat, to allow for expanded capacity and great flexibility. So towboats can be used to tow trailers or a variety of functions on their own. And we can take a look at that. So the basic boat is a power unit, a power and navigation unit, highly technological, that can avoid boats, move around the city much as you would if you were in a rowboat yourself. This rowboat acts in place of human driver. So there's a power base with all the equipment for autonomous electric mobility, and then various tops that can be put on, in this case, to collect garbage. So let's take a look at how this system could function in the city. And then I'll take a look at some of the electronics and mechanics for those engineers who might be on board with us today. Although our function, my function, and SA&P's function was the urban function to make sure that this system could really serve the city. So let's start out with transportation. There's a fundamental difference here, which is that currently the transportation is with these huge boats. They're very long and narrow. They're basically used for tourists, but on occasion do carry groups and other things around the city. But honestly, they're so big that they can't even negotiate the geometry of the canal system. And to replace this was a series of pixels on the water, each a small autonomous pixel that can arrange themselves in different ways and serve different functions, kind of like a swarm across the city. Now, as in many places, most of the action is in the historic city of Amsterdam still. For example, 90% of all the hotel beds are in the city center, if you're thinking about tourism. Or, even if you're a resident, and let's say you're staying near the Rijksmuseum, if you want to get to an attraction, because of the configuration of the city, you have to go out of the city and then return back to the attraction. So it's a very circuitous route. There are no direct road movement routes. And if you take the subway, the metro, which they have, it requires two transfers. So it's quite a hefty movement for many people. It's not straightforward. Same thing if you want to go south, you have to go out to come back. And one thing is you're usually coming out from the canal system and back to the canal system, since most of these attractions and productive activities are located along the canals. And even to the south, two transfers are required to get anywhere. So a pixelated, on-demand, and shuttle kind of service would be much more efficient, making use of the canal system that they already have, of the water system. And it seems like a simple thing, right? Sort of like an Uber on the water. But it really isn't, because if you look in this drawing, you'll see, they're stepping nicely onto this thing. But the canal edge, having been built over 500 years, is different in every single location. So how do you carry the ability to interface with the city on the boat? And this is one example of a top that I talked about that could be placed. Or if you have more people involved, you could use a towboat and 3 boats connected behind and carry and move a lot more people. Now, this isn't the only issue that has to do with mobility in the city. The other are these large canal boats that exist, the tour boats, in and of themselves. They're so large, and there are a lot of them, that there's no place really to store these along the canals. Where do you put them? So just from a really practical point of view, each boat every day, at the end and the beginning of the day, have to be brought out of the city center to a docking location somewhere to the north or the south. You add it up, this takes the driver of the boat. Usually, drivers own their own boats, or 2 or 3 of them are owned by a small company. 2,625 hours per year, and costs each one of those owners 26,000 euros a year to move around. It's incredibly inefficient. And when you think about it, you could use the towboat to tow other boats. And if at the end of the day, or when these boats came out of service, the rowboat was automatically organized to take certain boats out there, it would remove the need for human activity and all of the gas and oil that is burned in the process that pollutes the waters and so forth with this totally autonomous boat. Another, I'm sorry, I can't hear you all back, so if you have questions, I guess we'll have to wait to the end. But another really practical problem in Amsterdam is that people use the edges of the canals to live. This is something that's been part of the scene in Amsterdam. It's very romantic, since the 1600s. But it's a nightmare for the city to manage and take care of and to all of these boats. And you can imagine the owners, after a while, they may die or they may go off to other things, and they don't remove the boats, they just leave them there. So Roboat also provides a mobility solution for removing this and managing these boats. So rather than getting a parking ticket or being towed away, you can be moved. Your boat may be moved by Roboat into a more secure and better location for the city. All that it requires is an attachment mechanism, which we'll talk about in a little while. Okay, so let's move on. How about food or the distribution? It could be food, could be packages, whatever. Each of these, what we call use cases, requires really understanding how the city works. Now, Amsterdam is blessed because it has a very productive urban center, but it is surrounded by plan, by design, with a countryside that is highly productive for food. And here's Dietz, who has his farm growing carrots and vegetables 20, 40, 50 kilometers from Amsterdam. And if he wants to sell those vegetables in the local markets that are in the city, he must drive in a truck or in a kind of truck that collects across several farms. Let me see if I can read this. It takes an hour and a half of driving, 5 liters of gas. In a week, there's 6 hours, 20 liters of gas. You get the point. In a year, 312 hours driving back and forth, burning again, putting out carbon emissions, burning gasoline, and so forth. And there are 76 markets in the city to which people are all converging from the countryside every single day. That's a lot of transportation and movement, but 27 of those markets are right next to canals. So you actually have this web of transit. This is just the traffic routes coming to one market in the city, and all going along these small streets that weren't originally designed to carry them, past people's homes and everything else. And then all those trucks park at the market. And these lines you see here, the orange dotted lines, if you go to this particular market, all the trucks are lining up here, actually making it difficult for people to park and use the market, because you have the suppliers competing with the consumers, and it's kind of a mess. Yet right nearby here are a couple of different canals that could serve this function. And that same canal system provides a very efficient way for autonomously boats to collect the produce, join together into little trains and bring it into the city, and then distribute it in various ways, one of which might be this market. So this, again, every nice planning solution raises a very practical issue about how you create and serve markets in the city. And this little animation gives you an understanding of how that might happen. You have rowboats with tops which carry the produce. They can either act independently. So if I live in this neighborhood, the flour rowboat comes by every morning at 10 o'clock and stops for an hour and then moves to other places, or the food rowboat, or your package delivery, or whatever. Or you can use the rowboats to provide a platform to extend the area available for market-like activity. Remember that once you have the streets on the sides and the parking, which is all there along the canals, there's very little space for anything that might expand, even existing markets, and this can provide a solution for that. Now, the other practical technological problem is, how do the rowboats actually attach? And we've spent a couple of years working on various systems that would allow a secure attachment of the rowboats to each other and to the canal walls. And it sounds, again, like, well, you just clip them together, but actually not, because if you think about it, it's a three-dimensional system. The boats are moving up and down. There are all kinds of water currents, and how you get them to match up, not only in one way, but in multiple different ways, depending upon the situation, is actually quite a challenge. And finally, we've ended up with this kind of paddle system where the paddles interlock and then really pull themselves together, and it's completely flexible. And the boats themselves, given a need or a function, determine how to assemble themselves. So finally, James mentioned this. Let's go to the issue of waste. Now, Amsterdam is a large, dense city, and once you get things out and deliver them, what do you do with the waste? And that has become a difficult problem in the city. Why? Because either you have to have all kinds of bins everywhere, or you have to have large places where they collect and garbage trucks come by to pick them up. The garbage trucks are heavy, they're noisy, and they are degrading the environment of the walls and so forth, as I mentioned before. Now, the city has tried to tackle this problem with a kind of interesting, but for me, horrifying way of dealing with the garbage in a componentized way. You see on the right what looks like a trash can, right? A big belly kind of trash can. But it's more than that, because the trash, if you see on the left, is kept underground in a bin. This garbage truck comes along, and rather than just throwing stuff in it the way, at least I do, you put your trash can out to the curb and then these guys throw it in. This has a little crane that picks it up and bangs it around in the truck to make sure it all falls out the bottom, and then puts it back. Can you imagine the noise that this is causing for people who are living, and these are people's apartments right next to it. So it's become quite a nuisance in the city. Now, there's clearly no reason why we cannot do this from the water, which would at least more technologically reduce the banging and eliminate the fact that these heavy trucks need to rumble on the small streets in the neighborhood, and preserve better the character of the neighborhood. But it's still not really an ideal solution. So we've investigated several approaches to this, and we're talking about waste not just from individual homes, but also from hotels, from companies that are located within the urban fabric. There are many of them, including workshops and other things, and construction. To build a new building in Amsterdam is like a major undertaking. Even if you can find a site, or you're trying to restore an older building, you've got to get all this heavy material to the site and take out all of the demolition. So that's another practical problem. And what we determined after very careful analysis is that, depending upon how far you think someone is willing to walk, you could actually cover the entirety of the existing ancient downtown of Amsterdam with rowboats. And it requires surprisingly few boats. I'm just going on my memory here, but I think you can service all of the waste removal except for construction in downtown Amsterdam with about 60 of these rowboats. And the reason being is that they show up, they stay for a period of time to collect the trash. Once they're full, they automatically go and empty it at a central sort of location, and then either return to the same spot if there's more demand, or move on to another spot. So the actual number of rowboats that you need to service the entire city is rather low. It's very, very efficient. And it's also on demand. If it's needed, it's there, and we can provide all of the infrastructure on the boat itself, as I showed before. Now, construction waste is a whole different thing, but here's where the towboat comes into play. You could have a collection of rowboats taking the waste, and the towboat comes along, and when we're ready, silently and gently takes it all away. And you can imagine how much energy we're saving, how much noise and disruption that you save. Now, I promised up front for those who are sort of more engineering oriented to show some of the background on this, which I'll do in this video. This was Roboat 2. We went from a quarter scale to a half scale to full scale. This is Roboat 2. And you can just read the text. It can navigate constrained and complex urban waterways on its own. And of course, when you have students, they wanted to ride even the half scale. It was a little dangerous, I think. The 4 propellers that give it incredible mobility. And just like you, when you're navigating to a destination in the city, you pick local destinations first and move to your general destination along this point. And it's incredibly sensitive. The boats are modular. We can put them all together. They're each operating independently but collectively at the same time, or have followers. This is at the MIT graduate student pool. This was Roboat 1, when it was kind of like a toy. But here you see the trash collection system in a miniature scale. Okay, so just a couple of more things about Roboat. It's not just a transportation and logistical system. It's also a maintenance and functional system for the canals themselves. So one of the problems I mentioned was the instability of the walls. And the city is desperate. You know, these walls just collapse with absolutely no warning. You cannot tell. And the city needs some kind of predictive system so they know how to maintain the walls. At the same time, there are biological issues with the canals, algae growth, pathogens, and stuff. You can imagine what ends up getting thrown into these canals. And, dirt and other things carried by the water. The canals actually tend to fill up, so they have chemicals that have to be monitored. There's organic material that has to be monitored, and the actual structure of the canals themselves. So Roboat, because it would be this pixelated system using every canal in the city all the time, would be able to sense and provide a real-time picture of the condition of the canals and the water within them. So this was civil and environmental engineering's job to figure out how to do this across the systems of the canal. And to do it, we had a team on the water for the past, periodically for the past 5 years, developing the technology in a very compact form that can read the environment of the canal and report to Waternet, which is the agency that actually maintains the canal, on the real-time condition of the canals. And if you're interested, and I'll show a final video in a minute or two, if you're interested, how does it deal with the walls? Well, LiDAR radar is really the guiding light of the Roboat, and it is monitoring every second 20 or 30 million points along its environment. Could be people, could be boats moving, could be water, or now it is also focused on the walls of the canals. And it maps those walls, all the joints and everything, and can detect very slight movements and report, this wall is starting to sink, or this one is starting to move forward. We better go out and maintain it, and actually develop maps which can aid the city in maintaining the walls before they fail. So this is Roboat 3, which was launched in the fall. As I said, there were 2 other prototypes at different scales. And this is where the system is currently at. You can see it's not that big. It is a pixel. It's about it's 4 meters. No, it's 3 meters by 2 meters. So what's that? About 13 feet by 6.5 feet. It has this keel underneath it. Let me get to the next slide, where all the electronics and the batteries and everything are housed. And this is one key to the stability of the platform. You can imagine if you throw a piece of concrete into this thing, or if 20 people get on and they're all loading on the right side, it has to be stable in the water. So it has a kind of tuned mass that helps keep this thing perfectly stable in the water as a platform, and also the 4 propellers keep it very steady in the movement and can assist to stabilize it. So the keel is a very important piece of this, and let me show you now how it all operates.
This is Lucy. Lucy is a rowboat, a fully autonomous, zero-emission boat that operates on urban waterways, and she can change the way cities work. As congestion and emissions continue to rise, while cities continue to grow, the existing infrastructure of many cities struggles to keep up. Rowboats offer a solution by moving road traffic to the water. By bringing passengers from A to B, or as an on-demand boat, taking you anywhere you want. And they can also help the city as a multi-purpose workboat. Take Crystal. She is equipped to collect household waste to free the streets from heavy garbage trucks. Rowboats are fully autonomous, so they navigate without a skipper and can operate 24/7. In order to sail by themselves, rowboats need to perceive their environment and recognize objects such as bridge pillars, floating objects, and of course other vessels. The primary source of information comes from a LiDAR sensor, but rowboats are also equipped with cameras, GPS, and a digital compass. Roboat's onboard computer combines and processes all of the data and runs the Roboat software so it can successfully complete its mission plan. After 5 years of development, testing, and experimentation, we have now successfully enabled autonomy on the full-scale prototypes. Roboat is ready for the next step. Join us and let's unlock the potential of urban waterways together.
Okay, so that's it. And thank you so much. And I'm perfectly happy to answer some questions. Oh, and I'm back. Nice. Thank you.
Dennis, that was absolutely fantastic. Thank you so much. Really brilliant presentation. And we've already had tons of questions, but for those in the audience who would like to ask questions, you can either drop them in the chat, or if you want to just raise your hand with the raise hand button, please do, and I'll try and get around to you as quickly as I possibly can. Just to start off with, the city that you were working with, did you receive any funding from the city, or and what was your interaction like with the city? Were they supportive, or have they implemented any regulation? How has that all worked?
Well, the city was the initial source of funding for setting up AMS. They put, I think, about $60 million into AMS. That certainly that's hiring faculty and researchers and buildings and everything. And it didn't all go for research. The budget for Roboat was, I think, around $2 million over 5 years, something like that. And the city has been enthusiastically supportive of this idea for two reasons. One, it's an incredibly practical way for them to save money and maintain the efficacy of the canal system. But also for Amsterdam to put itself out there as a technology leader, because as you can see from the slides, this little project has launched a whole series of research and products in Amsterdam that constitute economic development for the city.
Brilliant. How has the local community, like the houseboat community, the tour boat community, how are they reacting to this? And also, while this is in the waterways and it's making use of the waterways, it's restricted to the waterways. So where else can this be implemented across the globe?
Well, anywhere that has a water system, some of the obvious places are Venice. These gasoline-powered boats, which most places use, are very destructive. They're destructive physically to the walls and the infrastructure, but they're also polluting the water and the air. So if you can have a totally electric system, you're really saving waterfront cities that have uses on the water. And we've come across cities that are interested in implementing this system in China, in India, in the US, and in Europe. If you think about it, most of the world's great cities and almost all of the historic ones that have cultural value are on water, and many of them use canals. So I think there's a built-in market. And you'll notice that it's not AMS, it's Roboat.org now, which is a nonprofit company that is seeking to develop further and to market the product. There are also a lot of profit-making companies that are interested in it as well. And the city is now struggling with whether they should lease the technology elsewhere or actually create a product that they sell. So,
Dennis, is this available right now? Is this actually working, or is it still a prototype?
well, it's a full-scale working prototype, which means that yes, if you wanted to use it as it is now, there's nothing to stop us from actually mass producing them. But the prototype, for example, because of we needed to produce them quickly to meet the requirements of the city to demonstrate this by 2022, was made of stainless steel. Okay, that's a pretty high-end DeLorean, and it could easily be made of fiberglass or plastic composite of some kind. And I would imagine if you went to full-scale production, you would move to a cheaper material, but it would still function identically. The electronics and everything, we're at a point in time where, although they're highly sophisticated, they're not all that expensive. The real value added here is the programming. It's the data processing that's done on board and autonomously, or through the cloud, of course. That is the real IP. That is the real source of value, not the little pieces of equipment that are there. They're all available for reasonable cost.
We have so many logistics questions involved with how this all works. Okay. I'm going to try and get through them all, but I'm not entirely familiar with all of the canal systems in Amsterdam, but in most other canal-based cities, there is locks throughout the cities that can get in the way and cause hurdles or issues, and more importantly, delays. Is that something that you found as an issue, or was that not actually relevant with Amsterdam?
Well, there are guard locks in Amsterdam,
okay,
that protect the system from storm surges and so forth, and the rowboats right now are within the guard locks, okay, because they're serving as an urban system. But there's absolutely no, in fact, we've done it, is no reason why this autonomous vehicle can't go through the lock system and out into the open sea, or on rivers, for example. I can't remember the name of the river in Amsterdam. There's a lot of going on there, so it does move out into the river. And it's it's amazingly stable, this thing. You can, if you think about it, you can have it in the water with the wind blowing and a heavy current, and it will stay absolutely stationary, adjusting to every little wave and wind gust.
Does this work as well in the open water as it does on we'll call it the calmer nature that is a canal?
Sure, yes, it does.
Okay.
The canals are not so calm. A couple of these big boats go by and there's waves and it's banging off the sides, and that's one of the problems. That's why an electric boat that's traveling at a reasonable speed will reduce the impact and wear and tear on the system.
So Amsterdam is well known for its nightlife and its exuberance of its tourists, we'll say. Okay. How do you stop people? Let's say you have a restriction of 5 people on it to keep it autonomous. How do you stop a group of 8 highly crazy, a bunch of people who've been out having a good time? How do you stop them messing it up the system and actually taking advantage, and then with that creating a dangerous situation or some sort of liability of maybe falling off or destroying some of the systems. And I'm sorry, I hate to
Well,
go down that road.
you
But
can't actually. I mean, it's the same with. I know in Australia and probably in European cities they have autonomous trams now, and we're going to have autonomous cars driving us around. If you want to destroy and vandalize the system, you can do it. But I can foresee the need for security on every one of these, and if you start rocking the boat, it just stops. You know, or if somebody can actually monitor what is happening on all these, and an algorithm can read them and just stop the boat, you don't go anywhere. Security, we were concerned about security with bikes because unfortunately these same folks that you're talking about in Amsterdam have a habit of, once their bike is old, throwing it in the canal. And we actually have a rowboat top designed to find those bikes and pick them up and put them in the rowboat. But we were concerned that people would start tossing them in the rowboat. Rowboats, and filling them up with dead bicycles. But if you do that, it will stop. I mean, actually any movement that is not what is normally considered practical, everyday use will bring this thing to a stop.
Gotcha. I kind of alluded to this earlier, but I think I distracted you with another question. But with so many other tour boats on the water and so many houseboats that are, where people live, how have the houseboat community or the tour boat community, how are they reacting to this? Is this something that they're on board with, or are they fighting you, and have you found any we'll call it obstacles along the way that have kind of said, our pushback really is what I'm looking for along the way with this journey?
Well, to be honest, right now we have the 2 prototypes and everybody's very happy about it and sort of celebrating it. It works and everything. Once you have hundreds of these things, pixels on the water, you might find some opposition, as there always is to new technology. Particularly when they start latching onto your boat because it's overparked or something and moving it out of the city. I can imagine there might be some reaction to that. But the canals are a logical place for this public utility, which is what it is now, or even a private one. Think of all the services that we have that we kind of put up with: delivery trucks, garbage trucks, all this stuff that rumble through our neighborhoods. Once this system is put in place, I think the public will support it. And so far, they have been very supportive because there are so many obvious benefits. But we'll see. I don't know the answer to your question. It's a good question, but I don't know the answer.
We'll start to kind of wrap up the questions in a second, but one of the issues that you mentioned, or not issues, one of the obstacles that you overcame was the latching system. Through this whole journey and through this whole process, what have been some of the larger obstacles that you've faced and that you've been able to, and how did you overcome them from that?
It was really due to the, in research, when you have this goal out there, that we would produce operable boats that could be demonstrated by 2022. It was the fall of 2021, which we did meet. The researchers were it just amazes me. Particularly the folks at CSAIL were just incredible. And they were very dogged, and there were hundreds of obstacles. I mean, how does a boat autonomously navigate with all these other boats moving around? And it's not like a car, everybody's in a lane, and there are markings on the streets and traffic lights and all this stuff. Basically, what's going on in the canals is a free-for-all with these huge boats. And to make turns, they have to go back and forth and so forth. And you have, people swimming once in a while in canals and all kinds of things going on. And how to develop a system this is why they went to a LiDAR system. Because what a LiDAR allows them to do, believe it or not, it's mapping millions of points every second. but as it showed in the video, it's assigning them a name and recognizing them as you would as a human being. Oh, that's a person in the water. I really better be very careful here. Or this boat is coming directly at me at it's speeding. I'm going to move right out of the way. And oh, there's another one over there. So I have to calculate the exact distance between them. It's a huge computational and sensing challenge. And the fact that that was overcome is just astounding to me, actually. The urban challenges are one thing, but the navigation and the sensing, to be able to have a platform that's stable enough to actually record the joints as you move along and see micro differences that could tell you when something could collapse is pretty remarkable. So every one of them was a huge obstacle. And that's why it's a kind of proprietary system of great value, I think.
One final quick question, in the interest of time, but can this system be applied to bigger systems? And what I mean by that is supply chain systems, like with boats, across the globe, which, is an area that we've seen, major issues over the last 24 months.
Sure. I think it can, but we're talking about a whole different ball game there.
Yeah.
And although this demonstrates the feasibility of these technological systems at a small scale, and I think everybody involved in the project would say, yes, they can be scaled up, that there are solutions to these things. I mean, as the boat gets bigger, in other words, one of the things that we encountered as the prototypes went from a quarter scale to a half scale to a full scale, all the mechanics, all the dynamics of movement and everything changes in the boat, and you have to tune the system to its mass and its use. And believe me, if you had a tanker out there, one of these container trucks would probably have a mainframe computer down in the bottom chugging along, or all this data flying out to the web. But of course, yes, these supply chains can be automated, as can the last mile of delivery for packages and so forth. It opens up a whole different world, and
absolutely,
I think we're going to see that. So.
Super, Dennis. This was an absolutely incredible presentation. I think everybody that's been part of it that was here has really enjoyed it. Some of the comments, I know you can see some of them, but some of them you can't. Have all been so supportive of the project, and they've loved every minute of it. So with that, I just wanted to thank you so much for being with us this morning and giving us your time and your expertise and your understanding on this. It's really, really been brilliant.
It's my pleasure, James. And it's interesting to see what real estate people can get involved in. There's a lot of, and I didn't even talk about the implications of this for value in those neighborhoods, for servicing different kinds of uses and so forth. If you improve the infrastructure of a city, it raises its value, its real estate value of individual sites and the entire complex. So
absolutely, a thoroughly worthwhile project, and one I think that we're going to see an awful lot of value throughout the globe. I mean thank you for making all of that happen. With that, I'm going to say to everybody, we conclude this presentation this morning. This particular Zoom link is going to stay open for the next half an hour or so to allow everyone who's on to chat or mingle and give you the opportunity to connect with anybody who is on and you mightn't have seen in a while. So we open it up to you. But with that, thank you so much for joining us.
Thanks, folks. It was great. It was my pleasure.
Thank you,
Take
Dennis.
care,
Okay.
Thanks,
Dennis.
Thank you, Dennis.
Thank you, James.